So what are the steps required to bridge the gap between your idea and an actual 3D printed object? First, you're going to need to create a digital file in CAD. CAD stands for Computer Aided Design Software, and in this course, I'll be using SOLIDWORKS for my CAD program. There are a wide variety of 3D CAD programs on the market to choose from, including open source programs like Onshape that can be downloaded for free. Any of these programs can be used to create a 3D print. One of the example models I'll be using in this course is called the 3D Benchy Boat. It was developed specifically for testing and benchmarking 3D prints in 2015 and can be downloaded for free. The download package also contains a PDF listing several data points you can check against to ensure the model prints as expected. Another common model used to test 3D printing is the Stanford Bunny, a computer graphics 3D test model developed in 1994 at Stanford University. Once you've completed a CAD model, it needs to be saved or exported as a 3D printable format. I'll go ahead and export my Benchy Boat as an STL, or stereolithography file. STL is the most common 3D printing format because it uses mesh data to define the model. You could think of a model mesh as a netting of different sized triangles connecting to create a 3D form. Here's an example of a simple mushroom shape using both coarse and fine meshes. You can see how the different triangles connect to create the model. Fewer triangles make a more faceted form, and more triangles make a much more refined form. As you can see, my Benchy Boat contains a pretty high level of mesh detail, so the resulting print should be fairly smooth. It's also important to note that STLs do not contain color data. Look for X3D, WRL, or Ply file types to print in full color. Note that you'll need a dual filament or PolyJet printer to print multicolored prints. I'll be focusing on single color FDM prints for the remainder of this course, but the lessons would apply to multicolor FDM prints as well. Once your CAD model is fully defined and exported, it's time to move on to CAM. CAM stands for Computer Aided Manufacturing and refers to any type of program that converts geometric design data into instructions a machine, like a 3D printer, can follow. I'll mostly be using Cura and a little bit of GrabCAD Print for the CAM programs in this course. Both are open source programs available for download. CAM programs for 3D printing are also known as slicers because they generate 2D slices which are then stacked to create a 3D object. This can be done using a variety of methods when printed. Some use lasers to cure resin or harden a powder. Others use thin layers of ink-like materials to create full-color, high-res 3D prints, and others extrude plastic through a hot nozzle, like the FDM prints we'll focus on in this course. Looking at our Benchy Boat in CAM, we can preview the model in both a 3D model view and in a sliced model view, showing you how the material will be extruded to create the print. You can see that each layer is built up upon the last to create the physical part. And you can also preview how each individual layer is filled. Once I'm satisfied with the slicer preview, I can click Print to send the coding required, known as G-code, to my printer, and the 3D print is created. The time it takes to complete the print can vary widely depending on your print settings and materials, but many slicer programs will provide you with an estimate based on your choices. You can make all types of physical products using 3D printing, ranging from prototypes to finished consumer products. And where traditional manufacturing methods were often limited, like dealing with undercut geometry, for example, 3D printing allows you to create nearly any form or shape imaginable. 3D printing is still primarily used for prototyping, but can be useful in any industry dealing with a digital workflow, like architecture, or even character modeling. And if you just need 10, or even 100 parts. 3D printing can be a great solution for making a final product, typically requiring a minimal amount of post-processing like sanding, painting, or individual customizations.